Hello and welcome to the continuation of the skeletal system. So here we are going to continue the axial skeleton, and in particular the vertebral column and the bony thorax, so to speak. So we're still not tackling bones of the limbs, so nothing of the upper limb, nothing that connects the upper limb to the axial skeleton, not the lower limb, not the pelvis that connects it to the skeleton, just the vertebrae, how the column fits together, and the bony thorax, which is going to be ribs for the most part. So let's get into it. First, I want to remind everybody that I'm going to be using a word a lot in the bone lectures. I'm going to use the verb articulate as a verb. So that means to form a joint. So I'm going to say things like, the sphenoid articulates with the ethmoid, or the parietal articulates with... Actually, why don't you tell me what the parietal bone articulates with? That would be good. You tell me what the parietal bone articulates with. 3, 2, 1, pause. So the parietal is going to articulate with quite a few bones, including the occipital, temporal, sphenoid, and frontal, and I believe that's it, but that's a lot of bones just the same. Okay, so that's how we use that. We say that this bone articulates with this other bone if they form a joint. And it might have surprised you that I just mentioned bones in the skull as forming joints, but that's the idea. Anytime two bones are attached to each other really in any way, that's a joint. And the bones in the skull have a special kind of joint that is very solid and stable and doesn't move, but it's still a joint. Okay? So with that, let's keep going to the vertebral column. So the vertebral column is going to support our weight and transmit the weight of our upper body to our pelvis, where our legs can carry it. It's also, it's attached to the ribs, and the ribs protect our thoracic organs. The vertebral column also protects the spinal cord and permits spinal nerves to exit the spinal cord. So all of those things have to be taken care of by the vertebral column, and it is very complicated. It's way more complicated than anything we are going to get into, but we are going to learn the basics of the column and the structures of the individual vertebrae. So to start with, its organization is that there are, I guess we could see 5 different regions. We're going to spend most of our time talking about the most superior 3. So the cervical vertebrae, where there's 7 of those. There are 12 thoracic, 5 lumbar. And then there are also, there's a fused set in the sacrum. And the sacrum is going to articulate with the coxal bones to make the pelvis. And then the coccyx, or tailbone, is another fused bone that's going to be the most inferior. So every vertebra, of which we have quite a few, is named partly based on which group it's in, and then based on what position it's in. So if you look up here at the thoracic vertebrae, the most superior one is T1, or thoracic vertebra 1, and the bottom one is T12, or thoracic vertebra 12. There are 12 of them. Same thing for cervical. Cervical 1 is at the top, cervical 7 is at the bottom. And we'll see cervical 1 and cervical 2 are special, kind of unique bones, but they all do go by this naming scheme. One thing you'll have to remember, this is kind of a central thing in anatomy, is the positions of the spinal cord. And so how many different vertebrae are there in cervical, thoracic, and lumbar? And there's a kind of traditional mnemonic device for remembering this, where if we're trying to remember the numbers 7, 12, and 5, we might imagine meal times for a Midwestern farmer on the weekend, where a person might eat breakfast at 7 a.m. and lunch at 12 noon and dinner at 5. I don't know if anybody follows this schedule anymore, but that made sense to people who were studying anatomy for many, many years. So 7, 12, and 5 is a good thing to remember. These are the functions I mentioned before, and you'll notice a lot of different things as you start to learn the vertebral column, one of which is that these groups of vertebrae are different. And if you knew enough about the vertebrae, you could actually tell any two of them apart. So each one is unique, but we are not going to get down to the level where we could tell T5 from T6, for example. You will definitely be able to tell any cervical vertebra from any thoracic, from any lumbar. They're different in a lot of ways, and you'll have to be able to pick that out. But also, you'll notice this curvature. So if we have this, so this right here is an anterior view, and then this is a lateral view, or side view, and the curvatures are kind of accentuated. And two of these curvatures, thoracic and sacral, are present at birth, so we call them primary, and then the cervical and lumbar arise when a very young child starts lifting his head and walking. And these are natural, normal curves. It is also possible to develop abnormal curves if, for example, we overdevelop muscles on one side of the spine. We can twist the spine to that side. Years of imperfect posture can tend also to overdevelop certain muscles and to lock certain joints that can lead to kyphosis and lordosis. So these are examples of that. So scoliosis is a sideways curvature. Kyphosis with this extra thoracic curve is common in older people. And lordosis is common in younger people, but especially pregnant women would show lordosis. And some of these are reversible temporary conditions, and others are more permanent and very difficult to treat. Okay, so the next slide is about the ligaments. I'm not going to test you on specific ligaments, and that's why I grade all of this text out. But the vertebral column is held together by a lot of ligaments. And ligaments, well, why don't you tell me what kind of tissue makes up a ligament? 3, 2, 1, pause. Yes, correct. Dense, regular, CT proper. So a ligament is made up primarily of the collagen fiber, the collagen protein, and it has a lot of tensile strength in one direction. And so there are ligaments down the anterior side here, the posterior side here of the body, and then holding together all of these projections that come off the vertebrae. And that will make more sense once you have started to learn the structures of the individual vertebrae. They also have intervertebral discs, and those sit between the actual bones of the vertebrae and absorb shock and prevent the bones from grinding against each other. Now, how much shock do these need to maintain? Well, it is quite a bit, because if you can imagine, if you jump, when you land on your feet, all the weight of your head immediately gets transferred to the top cervical vertebra. And that has to then transfer all that weight to the second cervical vertebra, and in between them is an intervertebral disc. All the weight of your head, your upper limbs, your thoracic organs, your abdominal organs, all of that has to be carried and transferred almost instantaneously to your fifth lumbar vertebra. And so it has to have an intervertebral disc to prevent damage when that happens. The intervertebral discs have kind of a fascinating construction. They have this inner sphere of water. It's gelatinous, but it's mostly made of water, called the nucleus pulposus. And it's what you could imagine, if you wanted, was that nucleus pulposus is like a water balloon. And that means if you were to push down on the top of it, it would spread out to the sides. But you couldn't shrink it, you couldn't compress it. So if you push down on top of it, it has to spread out to the sides. And it's surrounded by the annulus fibrosus. This is made of fibrocartilage and ligaments. And what this does is contain the nucleus pulposus. So if a strong force pushes down on the nucleus pulposus, and it will tend to spread out in every direction, annulus fibrosus resists its tendency to spread out. And together those two things form kind of an effective shock absorbing system. So you have the nucleus pulposus that gets pressed down and spreads out. Annulus fibrosus restricts its movement and has some elastic tendencies that will absorb some of that expansion. And also the annulus fibrosus is thick and it is made of cartilage, so just by itself there is weight on it and it can absorb some forces that way. This is a video you can go to that kind of walks you through all of that, and it breaks it down a little bit more. In case if you didn't understand my explanation, check this video out. Start around 140-ish. Okay, so then let's look at the structure of vertebrae and what they all have in common, or what most of them have in common. The structures listed on this slide are common to most types of vertebrae. So, for example, the body. This is the massive part of the vertebrae. So here we have a superior view, here we have a lateral view. And this is the part that holds the weight and transfers it to the vertebrae below. So the intervertebral discs, one would be here, one would be here. Then you have attached to it several processes. So you have transverse processes that stick out laterally, and a spinous process that sticks out to the posterior. The spinous process you can find on yourself if you run a finger down your spine. All those bumps you feel on your spine are spinous processes. So that's this. If you feel back for your spine, what you're feeling is these things. Let's see. Some other things to notice are that there are articular processes. So this is an articular process with a facet. This would be the superior articular process up here. Down here would be the inferior articular process. And the idea is the vertebrae that would be up here, its inferior articular processes would fit with the superior articular process of this vertebra. So I don't know if I'm going to be able to show you this or not, but I will do my best here. So sure, let's look at a thorax. No. So let's see. I'm just going to delete some stuff. This will be fun. Multi-selection, select area, select all that, hide. Okay, so here we have 3 vertebrae together. These are lumbar vertebrae. These are big, heavy vertebrae down at the bottom of the spinal column. So up here we see the body, the spinous process, and the lateral processes. What the lateral processes are going to do is provide attachments for muscles that are going to twist the spine, help us bend from side to side, things like that. They're also going to attach to ligaments that are going to stabilize the spine. What I want to draw your attention to are the articular processes and articular facets. So this right here is a superior articular facet. So where would the superior articular facet be on this vertebra here? That's the question. And if we look for it, it would be right here, and it would be articulating with the inferior articular facet of this higher vertebra. And then this one has its own inferior vertebral articular facet, which is going to articulate with the superior articular facet of this vertebra down here. We could then, let's see, I could add all of the various ligaments, and you can see kind of how they're attached. You can get rid of those. I can add some muscles and show you kind of where those attach, and you can see they're making use of the transverse processes. And if we keep adding muscles, I'm not sure this is going to work, but try it. No, that's a mess. Never mind. Okay, anyway, so that's what the articular processes are about. You're also going to find a lamina that's going to connect the spinous process to the transverse process. The pedicle is going to connect. It's actually everything here. So this right here would be the pedicle. It's going to connect the body to everything else. And that's the general structure of a vertebra. So I'm going to stop this video here, and in the next one we'll look at the differences between the different types of vertebrae, and then from there we'll move on to the ribs, and that'll be enough for today.